It's starting. Okay. Okay, so to find the z-score, I figured I think I know the formula, but of course I didn't know how to type it in to this document. But I think it's this right here. Let me see. Sorry, I can't see what I'm doing. Is it that one right there?
Yep, that's it.
Okay. So that's what I would have typed if I could have figured that out. And then I couldn't figure out 3. What is the probability of randomly selecting individual observation is between 5 and 15? I mean, my problem is I have all of these different formulas. I even printed them out, but I don't understand what formula to use for what. It's just, my brain's not wrapping around it.
Okay, yeah, I had that same problem. And what I realized is if the question doesn't say anything about sample mean, then you don't use that formula. So there's the one that you just showed me. That's the sample mean formula.
Okay. Let me write that here.
Where it has like X with a bar over it. That's sample mean.
Okay.
And then the other formula that we've been using, it's the same thing, but without dividing by the square root.
Okay. That one?
Yeah, so that one you'll use if the question says something about standard deviation distribution. Any of those kind of words, that's what you'll use that one for.
Okay. And are those the only 2 formulas?
There's one more. It's the sample mean one, but without the square root part.
The one that we learned like right at the very beginning?
Yeah.
This one?
Yep, that's it.
So the one we have to find the z shape, z size?
Yep.
Score, z score. Okay. So. And what am I looking for if it's asking what, is there a specific wording that I'm looking for that one?
That one's, yeah, if it's asking for z-score, but you don't see like sample mean in it, then it would be that one.
Okay. Now I'm going to write all these in one place so that I... Okay. So then on 3A, Was the probability randomly selected individual observation is deemed? I don't understand.
Okay, so this one I just watched the video because it didn't look like there was any kind of formula you could use for it.
Okay.
And it looked like the hardest question, but it's not on the homework. So it'll be, I did the homework and the homework quiz, and this isn't on it. So that's good.
Okay.
But I think it's just wanting you to visualize it.
Okay.
So it's saying that if the population has a mean, let me see if I can pull up the picture of it really quick. Let's see. Okay. Okay, so this is saying that the mean is right in the middle right here of
Right.
10. And then the two numbers it gives you are 5 and 15. So let's see. And a standard deviation of 5. So -1 and 1, that means it's 1 deviation from the mean.
Right.
So if this was 10 and 1 deviation from the mean positively would be adding 5, which would give you 15.
Mm-hmm.
And then the other way would be 5.
So it's a 65, that rule thing?
Yep, that's exactly what it is. And so it's asking the probability in between here, the blue area, which is that 68.
Oh. Why didn't they just ask that question?
Right?
Okay. So there's not a formula. We're just supposed to, I mean, how did you
Visualize
figure that out? Did you just?
I just watched the tutorial of what the guy was doing. I think it just wants you to visualize it because there's not plugging into a formula.
Okay.
I think it's just checking to make sure you understand what standard deviation means.
Okay.
But I'm not sure. It was kind of hard for me too.
Okay. What is the 40th percentile for this population? How do I find that?
So this one,
Do I put?
okay, so he typed in the 40 percentile up here.
Right.
And so all of this is 40% all up until this line.
Okay. So do we put the z-score as the answer?
No. So once you get the z-score, then you can plug it into the formula that's not about sample mean or anything like that, just the regular one that we've had. The formula to find the z-score.
This top one.
Yep, that's it.
And I tried to print out this thing so I could write on it. mess it up, but of course I can't figure out my printer either. It's so good to be stupid. Okay, so once I get the z-score from plugging in the 40th, score is 253. Where do I go from there with the z-score?
Okay, so then this is the z-score, the 0.253,
Right?
and you plugged it into the formula, and did you
Sorry,
get
out to you. I'm not looking at it. Okay, go ahead.
what did you get when you plugged it in?
I don't know where to plug the z-score in.
Oh, okay.
Am I solving for x?
Right. Yeah.
Okay. Is this what it's supposed to look like?
Yeah.
Okay. So, okay. 253 times 0.5 equals 0.1265 add 10 9.265 equals x. No? What did I do wrong?
You said you got 6.5 equals x?
I got 10.265 equals x.
Let me see. 253 equals x minus 10.
This is what I did. What did I do wrong?
Times it by 5. 5 plus 10. 1 second. Let me see. I enter into my calculator what it says. Um,
Oh, I put the decimal in the wrong place, I think. Maybe.
Oh, it's a negative 2.3. See if that changes anything. Yeah, okay, so it's a negative 2.53.
And how, oh, because it's on the left side, right? Is that how we know that?
Yeah, if you look at this graph right here, the 40th percentile, the negative 2.53 is everything over here.
Okay. 2.53.
All these questions are kind of like reviewing the old. I didn't figure that out though at first. It took me a long time. It should be 8.7.
What is the answer supposed to be? Because I don't think I got it right still.
It's supposed to be 8.7.
I'm timesing 5. No, 0.5. 0.5 times.
It's just 5. The number 3 says the standard deviation is 5.
That's no problem. I did the stupid dot for times and it's messed me up. Yeah. 253 times 5 equals plus 10. 8.735.
Yep.
Okay. I have paper so I could write off this unit. Okay, what is the z-score for the observation of 18.5? See. So we're looking for a z-score.
Mm-hmm.
And not a standard deviation. Sample means no. So it would just be the z minus x minus population mean over standard deviation.
Yep.
Okay. So score. 18.5 minus 10.
Yep.
Bless you.
Thank you.
Over 5.
Uh-huh.
Mm. 1.7.
Yep.
Okay, what is the probability that an individual observation is greater than 12? Is this the one that we take 12 from 10?
So whenever you see probability, it means it's a two-step problem. So the first thing you're going to do is find the z-score, and then
Probability means okay, sorry, go ahead.
so you'll first find the z-score, or you'll use that formula to find whatever it is asking you. It's usually going to ask you for the z-score.
Okay.
And then you'll take it to the applet, and the applet will give you your answer.
Okay. So for this one, it's looking for the individual observation is greater than. So is that the same?
Yeah, so observation just means X. They'll say observation or value or anything like that, and it's what you plug in for X.
So it's the same formula I just did.
Yep.
Right?
Yep.
Okay, so 18.5 minus 12? No? No. 12 minus 10. Right?
Mm-hmm.
10 minus 10 divided by 5. Point 0, no, 0.4. Where did it go? Okay. Oh. What does it say? It's greater than, so I do the right side. Correct? 0.4.
Yep.
I mean 0.4. So the answer's 0.3446.
Yep, that's it. So this one is another visual one.
E.
Mm-hmm. So we can go the long about way and figure it out with the formulas, or the way the instructor explained it was this probability applet. We know the mean is 10.
So
and
it's
then
the same because it's just one deviation away. No.
Yeah, I was saying because it's wanting to know what's in between 12 and 8. We just found out what 12 was. And so this is everything for 12 and over. And then
Wait a minute.
10 minus.
Let me get back to where you are because I'm looking at my. Where are you?
Oh.
Where are you? Okay, here you are. Okay, sorry, go ahead.
Okay, so it had where our mean is 10, so it's right in the middle. And then we just found out in the last problem that this is 12 and greater.
Okay.
So 10 plus 2 is 12, which would mean that this has to be the same distance too, which would be 10 minus 2 is 8. And our problem wants to know everything less than 8 and everything greater than 12.
Where you get 2?
So the 2 is just, he was saying that if the mean is 10 and this is 12, you know that this is 2 points over.
Oh,
and
okay.
so it has to be symmetrical. So this red line has to be 2 points over the other direction.
Yeah, okay.
Which would then be 8, 10, 12. That kind of makes sense.
It does. I mean, it does make sense, but is it asking the same thing that the first one was asking? So the 0.68?
So this one's a little bit different. It's asking you what the probability is that it's less than 8 and then greater than 12. So it just happens to be 0.68.
Oh. So that is the answer, but it's not necessarily following the
right. Yeah.
steps that we did before. Okay.
But I mean, there's a mathematical way to figure it out too. If you want to go over that, we can.
And how is that?
Okay, so for D, you already found out what the probability was that's greater than 12 for letter D. And so now for letter E, you want to plug in 8 in your formula to find out. It's just finding the z-score again, but for 8.
Okay. So 8 minus 10 divided by 5. Is negative 0.4.
Yep.
And then we have to so you plug that into the applet.
Because it's the 2-step problem.
Okay. Okay, cool.
And so then you would know to highlight because it wants everything. This is your z-score for 8, and it wants everything less. So you'd highlight that part. And then this is your z-score for 12, and it wants everything greater. So you'd highlight that part.
Okay. Okay.
Does that kind of make sense?
It does. It makes sense when you're on the other line. Okay, suppose pair computing sold an average of 45 phones per minute. Yes, that means it sold. I can't even say that number. With the standard deviation of 10, they looked at their phone sales data and determined that they are normally distributed. Sample of size B full are taken from a normally distributed sales. What is the shape of the distribution? Well, it's determined that it's normally distributed, so it must be normal, right?
Yep. That's what I got.
You can do these ones.
Did you get that answer? Yeah.
Sample. Move on. Sample of size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution? Well, it's over 30, so it should be normal, right?
Yep.
Oops. A sample of the size n equals 4 is taken from the normally distributed 2000 sales data. What is the probability that the observed population is greater than 40?
Yeah. So this one, because it says probability, we know we're going to have to do the applet. But because these questions are now talking about distribution and sample, we're going to be using the sample mean formula.
Distribution, which is that one? No.
It should be the X with a bar on top minus 10, the little mu sign.
Okay.
And then divided
Oh, the sample mean
by
formula?
standard divided by the square.
Did you say the sample mean formula?
Yeah, so the sample mean is the X with the bar on top.
Okay.
B.
That one.
Z-score, but the sample mean is the exact same one, but where the Z-score is your square root.
That one.
Yeah. Yep, that's it. Get the sample mean formula, but that's not what it's called. The sample mean is the variable, the X over with the bar on top. That's what sample mean is. But whenever you see in questions, if it's a muted or sample mean, that's the formula it's talking about.
Because this number 6, it doesn't say anything about the sample mean.
Right, but it has right here, it's talking about distributed, and so that's when we're going to use that formula.
Okay.
And you'll see too in the big header part, suppose pair computing, they're giving you all the things to fill it in with. So an average, that's sample mean, and then standard deviation, normally distributed. Those are all key words that are telling you to use that formula. If that kind of makes sense.
Kind of. Okay, so
one of the big giveaways is if you see a sample size n equals anything, you'll use that formula.
Okay. Sample size. So 40 minus 4 is a standard deviation of above. Standard deviation of 10 divided by what's the sample size?
Sample size is 4.
What's the mean?
The mean is up at the top, I think. So the average of 45.
Okay, so 40 minus 45 divided by 10 divided by the square root of 4.
Mm-hmm.
Right?
Yep.
Let's see if I can type it into my computer. Minus 45. The negative 1.
Yep.
Seven. Sample size and, oh, there's that. So I must need that to use the formula, the Z formula. And phenomenally distributed. What is probability that the observed X is greater than 35? Probability, so
Mindy, remember because number 6 is it says probability, it's a two-step problem.
Yeah, I just thought of that when I was reading through 7.
Oh.
So I need to go to my applet. And put in my z-score of a negative. Wait, it wants to know. So how do I know on this one where I shade? Because it's a negative 1, do I shade the left?
Uh-huh.
Okay. So the actual score, or the actual answer is 1, 5, 8.
Yep.
7. Okay. Normally distributed, is it probably the percentage is greater than 35 and less than 55? Is this the visualization one?
This one I think you'll have to do by math, but yeah, it's the same, the exact same one that you did earlier.
Okay. So I do 40, 41 minus 45. Is that the number? Over 10. Is that right? 41 minus 45 divided by 10.
Should be 35 minus 45.
You're right. I don't know where I got 41. It's weird. Oh, it's the next question down. I
Oh,
thought I was going crazy. 35. Well, maybe I 10 divided by 10 is 1. With the same answer? Did I do something wrong?
do you have 35 minus 45 divided by 10 with the square root of 4?
Nope. I didn't do the square root thing.
Oh,
I
okay.
thought it was a different one. I wonder. Okay.
Because you're trying to figure out what's greater than 35 and less than 5 and your standard deviation. Best did your math wrong.
Doesn't make sense. We're told this. Oh, so it'd be less.
So your standard deviation is 10, but this is your z-score.
No, but see, this makes sense. Like the mean is 45, right?
Mm-hmm.
This would be 45.
Mm-hmm.
So standard deviation, one standard deviation to the left would be what?
35.
One standard deviation to the right would be what? The reason it's wrong is because it's for the sample. This is the term.
Oh, okay.
And for the sample, it means the standard deviation is small.
Do you understand?
You're talking to me. I can't see you guys, so I can't tell if you're talking to me or if you're talking to each other.
Sorry, I was talking to her. I just didn't understand number 7.
He's trying to work through it too.
Okay.
Okay.
So I got -2, but then we have to put it into our amplet, or is that what it's called?
Yeah. Yeah.
And we put it, let's see, less than, so we put it on the left side.
Mhm.
Point
But
0.
this question is asking for the probability in between two numbers. So you just found the z-score for 35, and now you have to do the exact same thing for 55.
So I do 55 minus 45 over 10 divided by the square root of 4.
Yes.
So what would be one distribution? Back.
Okay, so
So we
What did you get for your z-score?
For my z-score, I got 2.
Yep, that's right.
So then our answer is 0.0455.
So now because it's asking for probability, you have to take those 2 z-scores and plug them into the probability app.
Right, that's what I've done.
And when you put -2 and +2, and you want to know the probability in between those 2 numbers, you should get 0.95.
Oh, so I blew the middle, not the...
Right, yeah.
Okay. I just got a text from our tutor. She said, I had 2 major exams this week. Would you mind if we get an appointment next week? That's not really going to help me for this week. It's a good thing I have 2 classmates that can tutor me. Okay. Okay, point. Okay, the sample size of n equals 25 is taken from the normally distributed sales data. What is the probability that x is greater than 41 and less than 49? We do the same exact thing.
Yep.
Right.
It's the same.
Let me do the same except in changed.
Yeah, same formula, but the numbers are different.
Yeah, okay. So
That threw me.
Oh.
41 minus 45. Let's see.
This is tricky. Tricky stuff.
Oh, wait a minute. But instead, we do 10 divided by 20, 25, or the square root of 25.
Yeah. Mm-hmm.
It's the same thing.
Yep.
Yes, you. That's not very nice to make us do all that math. The same. Just kidding. Okay. Okay. Sample size of n. Distributed size. What is the probability that the observed is greater than 50? Is it the same formula, just doing it once?
Yeah, if you see n equals or it says anything about sample size, it'll be that formula.
Okay. So 50 is 45. .006.
Yep, so I got that's what you got too, right?
Yes.
Hmm. Okay. Pair computing sold an average of 40 in 2010 with a standard deviation of 12. They looked at their P-phone sales data and determined that the distribution is right skewed. Sample size n equals 4 are taken from the right skewed P-phone sales. What is the shape of the distribution of X? I would say right skewed because the sample size isn't big enough. Is that right?
Yep, that's what I put.
What you put?
Yeah, that's what you got, right?
Is it right?
Yeah, it is right.
Sample size of n, 40 are taken from the right skewed P-phone sales data. What is the shape of the distribution? That would be normal, right? Because
Yep.
the sample size is bigger.
Is that what you got, Michael?
Or is that one that's approximately normal?
I think it means the same thing. Like, I think approximately just means that it wasn't originally normal to begin with.
Right.
Okay.
That the big sample size made it approximate. So yes, you're right. In the answer key, it says approximately normal.
Oh, it does. Okay.
Just to be exact.
Just to be exact, approximately normal.
Right?
Okay. Is there a theorem that justifies your answer to question 11? What is the name of the theorem? It's the, I should have it memorized. I've read it so many stinking times. Central limit?
Yep.
Michael?
I was talking to myself.
Oh, okay. That's okay. Sometimes we need to be our own friend. Okay. A sample size of n is taken from the right skewed. And you want to know the probability that the observed greater than 35 can 35. The observed is greater than 35. Can you compute this probability using the normal probability applet with the information you have? Why? I don't think so. Don't we have to get our z first?
So you can't, and the reason is because the distribution isn't normal. It's right skewed, and the sample size is below 30.
Okay.
And the applet is only for normal.
Oh, okay.
Yeah.
Normal distribution.
Mm-hmm.
Okay, a sample size of 36 is taken from the right skewed p-phone cells data. What is the probability that the observed x is greater than 36.5? So that's a two-step because this is probability and it's an n, so we use the formula that we were using earlier, correct?
Yep.
Awesome.
Oh, that's what you're working on.
I've asked two people have asked me if I'm a statistician because I'm taking this class. I got really hard at them. I'm not. Okay. Standard deviation, is that information up above? Yeah, okay. So we do. Bless you.
I don't know why I'm saying
35 minus 40. Mm, 12 divided by.
That's wrong.
Oh.
Yeah, that's
What's our n? What's our sample size on 14?
It should say in the problem 36.
Oh, 40? Right? 40?
36, number 14.
Oh. Where's 36? Oh. 30. So it's 36.5 minus 40. divided by 12. No, 12 divided by, yeah, divided by 12 divided by 36 squared.
That's what you got right, Michael.
What?
The mean right here. Yeah, 12 divided by 36 squared.
Yes, yes.
And then on top is 36.5 minus 40, right?
Right.
Okay. -1.75, -1.75, and then .401.
So it wants to know what's greater than 36.5.
Oh,
So did you highlight everything to the right?
to the right of the, including the middle.
Yeah.
0.9599.
Yep, yep.
Yeah.
I gotta tell you something funny. Lighten the mood. My 13-year-old goes downstairs after everybody goes to bed for his bedtime. He sleeps in the basement, and he's got his bedroom and bathroom and everything down there. He goes down and he jams out to Newsies and The Greatest Showman, and he doesn't know that we can hear all the way up the third floor. Absolutely love it. I'm like, dude, you just jam all you want to those things.
I just showed Michael the Newsies. He'd never seen it before.
Oh,
He liked it.
it's pretty good, huh?
Yeah.
And Rexburg has that $2 movie theater, and they show The Greatest Showman here. So that's pretty nice.
Yeah.
$2.
Yeah, my
6
both
kids,
my
right?
boys. Yeah, my two boys and their wives go to that theater a lot.
Oh, are they in Rexburg too?
Uh-huh. I was saying to my daughter who's in Provo that when we all pass this statistics, you guys and me pass this statistics class, we have to go out to dinner.
Yeah, seriously.
Because I'm just in Idaho Falls.
Okay.
We're just there today. My specialist is in Idaho Falls, so we go there for the doctor appointments.
Oh, really? Yeah.
So, what is the range of your kids, like the oldest to youngest?
So my oldest is 25, and then my youngest is 7. So I had my first 3 by the time I was 21. My husband and I got married right after he got home from his mission, and we met, and anyway, and we had babies like this. And then I couldn't get pregnant for 8 years. Had secondary infertility. And so we have like 2 families. The Lord, we let us have a practice family. And now we're
That's what we need. We need to practice one.
It was so hard to not have those last 3 coming, but we sent our parents on missions, and every time they went on a mission, I was able to get pregnant. So
Oh, wow.
it's true that when you send your family or when your parents go on missions, your family is blessed. So,
Wow.
Awesome. There was an elder one time who was complaining about his dad gave his car while he was on his mission to his younger brother. And I said, oh, look at that, elder. Your mission's already blessing your brother.
That's funny. Okay, let's back to work here. 15. The sample size 36 is taken from the right skewed. What is the probability? This is between. Okay, so this is a between thing again. So 3, 7.5.
Got it?
Yeah. I think.
Yeah. I'm pretty sure. What's up?
Okay.
I think that's right.
Oh, yeah.
Sorry, I'm hurrying. Hopefully our quiz will be really fast.
Oh, we still have to take the quiz, right? I forgot about that part. Quiz.
Wrong. Okay. It's between. I did something wrong. I don't know what.
What'd you get? What were your z-scores for that one?
Okay, so do I take 37.5 minus 40 divided by 12 divided by the square root of 36?
Yep.
And I got negative 0.25.
I think it's negative
I can't hear you.
1.2. Negative 1.25.
For some reason, I can't hear you anymore.
Can you hear me now?
Oh, great. What's wrong?
Can you hear me now?
Can you hear me, Mindy?
Nothing?
Uh-oh.
Maybe if we just restart the call. Can you hear me?
Should I go out and try it and invite you guys again?
Yeah.
Okay.